Are you really facing an issue to identify space and time complexity for a single problem? But after watching this video, you never face that. Hi guys, welcome to my channel Sansora. Today we are going to discuss about this time complexity and space complexity. And in my DSA series, I am going to teach the coding in Java, C++ and Python as well. I am going to write the code in C++ here, but Java, Python codes also I will provide and explain the code how I am going to write. Okay, yeah, let's get into the video. Today our topic is time complexity and space complexity. To identify space and time complexity, I am going to explain with a real life example. There is a pizza guy. He used to be deliver one pizza in 1 minute. Like a pizza guy, he takes 1 minute to deliver one pizza. Okay, and this is to by walking. Like he don't have any vehicles or something. By walking, he can deliver one pizza in 1 minute. This is one pizza. But what if he has a 10 pizzas? He has a 10 pizzas, then he needs 10 minutes. What about 100 pizzas? 100 minutes. Right? Because he taking 1 minute for one pizza to deliver. And that to the approach is by walking. 1000 pizzas. 1000 minutes. Okay, you're getting it right. But do you observe anything here? The count of pages is increasing. Pizza count increasing. The time also it is increasing. You're getting it right. The count of pages are increasing. The time of execution time is also increasing, right? The time is also increasing. So what you can observe is time increases, or like number of pages increases, time also increases. And right, previously one pizza he can take, the number of pages increases, time also increasing. And one more thing, if he has one pizza he can take by hand, but if he has a 10 pizzas now, he need a bag. What if he needs to deliver 10 bags, right? What if he needs some car. 1000 pizzas he need a truck. What you're observing, the space also increasing. Space to complete that process also it is increasing, right? Space also increasing. What is this method? Like by walking. Okay, what if he delivers by using cycling? Okay, if he delivers it by through cycle now, he will take for 1000 pizzas, he take only 500 minutes. Okay, this is cycling. What if he has a bike or a car? Same pizza count is 1000 only, but what is the difference is he can deliver this by 100 minutes maybe. What if he needs, like for suppose he has a drones to deliver pizzas, then it will take around 50 minutes. So what you are observing, clearly seeing that, clearly say, if you follow some basic approach, if you follow some traditional approach now, what you are getting is the n increases. If you follow the time also increasing, right? Traditional approach, one single basic approach. Okay, but if you time increasing and space also increasing, but if you optimize the process, previously you used to walk, like by cycling it will take 500 minutes, bike or car it will take 100 minutes, drones it taking around 50 minutes. Previously how much? 1000 minutes. Now it is 50 by 15 minutes. If he doesn't have 1000, like doesn't have 1000 pages now, he can deliver by walk itself. There is nothing, because the time is very less, 1 minute only they are taking, 1 minute. So what if he has a lot of time, a lot of pages, he should deliver in better way, right? You're getting it, right? So this is, we should have to think for it. Based on the n size, we can change the approach. Change the solution, like optimization, what we call as optimization. Based on the size of the array or input, we can optimize the process. This is what we are following in this series. Okay, you're understanding, right? If n increases, increasing, time also increasing, space also increasing, and that too, if you follow the traditional approach, it doesn't change anything. But if n increasing, if you follow some new optimizations or new approaches, your time is reducing, right? You're optimizing code, so the time of execution is less, it is reducing. So this is what you have to think. Based on the input size, you have to think for a solution that will be useful for your everything. Okay, you're getting it, right? This is the general concept. This is, you got to understand. N increases, optimization needs optimization by another algorithms. Okay, by algorithms you have to optimize the code. This is one thing. Okay, now you can see this something here, like for this is a for loop, you guys know this, right? It will run in n times, right? Whatever the code inside the for loop, but we ignore as of now how many times the for loop will check. I starts from 1, I compare less than or equal to n, and I plus plus. Let's say here is 1000, right? So 1000 pages. So it is going to happen, it will take around, the for loop will execute nearly 1000 times. So if you say the time complexity, previously we are saying about 1000 minutes, right? Think like that. And if we ask about what is the time complexity for this for loop, you can say it is taking, the input is n, and the for loop is also executing n times, right? So consider this and say that the time complexity is order of n. Order is do you know, I forgot to tell you is one more thing. Order of n. So what are the time complexity we are going to do in a coding or something? This is going to be worst case scenario, we call it as big O notation. Okay, big O notation. This is a worst case time complexity for a single problem, we are just thinking for it. So based on the worst case scenario, we are going to give the time complexity for a single problem. Okay, so if it is a worst case now, so it will applicable for all the problems, so we are going to give the some accurate, at most it's not an exact time it is not the exact it doesn't calculate the exact time, but it will give you some idea how much time it is going to take for a problem, for a developer or any inside it. Okay, you're getting it, right? Yeah. So it is a big O notation. Big O notation we can define with the O in front of it. Later use what are the input sizes. So this is order of n. Big O notation. It's a symbolization of big O notation. So big O notation means worst case time complexity we are considering. This is n. Input. This is input and this is big O notation. So the time complexity of a single for loop is with input size is n. So it runs in n times. We can consider that and we'll make that as order of n. Okay. Yeah, this is a two. Take this example. Here it takes 2 loops. And what is, I think we already calculated the inside time complexity. what is the time complexity for inside? We already calculated with this, right? We got as order of n, right? What about the outside one? Outside one also it will take order of n, right? Loop is the order of n, and outer loop also order of n. So what you can observe is it executes for every order of n. So like the time complexity is order of n into order of n, right? Because it executes every time. When it is a 1, it will execute 1. It execute 1, it execute again 1. Or you can, if you want to, like after order of n into n, we can consider as order of n square, right? You can guys think why it is order of n in front of a normal order of 1. But if you calculate this 1 into order of n, 1 into order of n, 1 into order of n till n times, the calculation we can get is as order of n into n, so order of n square. The time complexity itself is order of n square, okay? This is a time complexity for a for with 2 loops, okay? Okay, this is another example, okay? Tell me what is the time complexity for this problem? It will take order of n and I less than or equal to 3 into n and I plus plus. How many times it is going to execute? 3 into n. No, just like it executes normal n times, but it executes 3 times. So what is the time complexity? Order of 3 into n, right? But one thing you should fix in mind is what are the constant values are there in it to calculate a time complexity or something. We can consider those as a constant, we can ignore that. So this time complexity is also order of n only. We can ignore all the constants in it. We can ignore all the constant, remember that. We can ignore all the constant, we can get it as the order of n. Okay, take another example as well. Okay, you can understand that. Tell me now, I equal to 1, I less than or equal to n, and I plus are equal to 2. So what is the time, how much time it is going to execute? For suppose n equal to 1000, but the for loop itself is execute 500 times. Why? Because we are not directly following the sequence, we are just incrementing the I by 2, right? So what is the time complexity for this? Order of n by 2, right? This is right. But in real life we talked about the constants are considered as, we can ignore the constants actually. So what the time complexity? Order of n. Still it's an order of n only. Okay, this is taken another example. It will take from I equal to 1 and I less than or equal to n and I plus plus. So that execution of first loop will be order of n times. But what is the thing is, j is starting from I plus 1 and j less than. So what you can observe is the second loop is doesn't execute order of n times every time. It doesn't execute. So how it is going to execute is, for the first loop it will execute I plus 1 to I. So the first I equal to 1, then I plus 1 is 2. It executes 2 to 1000 if you think n is 1000. So the first loop will the first time it will execute order of n minus 1, second time order of n minus 2, third time order of n minus 3, fourth time order of n minus 4 times, third time. Okay, so if you identify that pattern, you'll get that it's a sum of integers. So what is the formula for sum of integers? N into n plus 1 by 2. If you apply that pattern, what you are going to get? N square plus n by 2, right? So n by 2, n plus 1. So automatically if you want to calculate like plus 2, plus 3, plus 4 or condition, a lot of things will come if you try to calculate the time complexity. So in general, so calculate everything, it will take around n square plus n only, but we consider this as a n square. If you try to calculate, if you want to compute everything with a number itself, it's a wrong thing to calculate n square plus n by 2. If you get into n by 2 into n plus 1 by 2, but to identify it's how much time it is going to take in general view, it will be difficult to identify the time complexity for a single function or something. So in general, we can consider these also as a n square. N square plus n is there, but so time complexity is order of n square only. But what if n square into n is there, but we can't consider it as order of n square? Only plus will be there. So if we multiply that now, we'll get as order of n square, order of n cube, sorry. So time complexity is this one. So both are not equal. N square plus n is not equal to n square into n. Okay. So we already understood that what is the time complexity for this code? Only for one for loop with I equal to 1, I less than or equal to n. So the time complexity for this is order of n. What about this? I equal to 1, I less than or equal to n. I1 equal to 1, j equal to 1, j less than or equal to n, and j plus plus. So it will take order of n inside. It will take order of n inside outer loop. So to get to multiply both the things, we will get as order of n square. And the last loop is also take order of n. So what is, if anybody asks what is the time complexity for entire program? In this program, you have 3 parts. Each part consists of separate time complexity, order of n square, and order of n. So if you want to find the time complexity, so what you're going to do? Order of n plus order of n square plus order of n. So we previously discussed, if it is a plus now, what is the maximum value? We can consider that. So what is the maximum? What is the maximum of init n square, right? So we can consider as order of n square. The time complexity for entire program is order of n square, not of order of n plus order of n square plus order of n. We previously discussed, right? We should be generalized. We are saying the time complexity in general. Okay, the time complexity is order of n square. Okay, take a last example. If I equal to n, 1 and I less than or equal to n and I plus plus. So the time complexity for outer loop is order of n. What is the inner loop time complexity is j equal to 1, j less than or equal to m, and j plus plus. So the time complexity inside is, it will reach up to order of m. Not, and here the variable is changing. So complete time complexity is order of n into m. You're getting it right? And these are the things are just for loops. For loops, time complexity. And we have a lot of other things in time complexity as well. We have binary search and prefix sum, polynomial sum, and like we have to find subsets, and we have to do recursion, we have to do permutations as well. So these are the things will take a lot of time. I will explain all the time complexity by explaining the algorithm, and I will explain the time complexity for each algorithm in it. Okay, I will explain all those things also. And these are the things from my side. Okay, you understand the time complexity, right? The time complexity is one of the important thing to in a DSA. So based on the input size itself, we have to change the solution what we can identify. For suppose think like if n itself is 10 to the power of 8, so we can't solve this problem in order of n. We can't solve based on the input itself. We have to optimize the solution. Thing, like we have to think for an optimized solution. What the pizza guy is delivered pizzas through walk, through cycling, through bike, or drones. So based on the input size itself, if the n is increasing, you should have to improve your optimized code. You're getting it right? Okay. If you like the content, share, like, subscribe. Okay guys, bye bye. We'll meet in the next video.